Good morning, everyone. I hope everyone is okay and happy. I hope everyone is fine. We are now starting with our lesson. So I hope everyone is good and ready to interact in our lesson today. And yes, we are almost done with the revision because tomorrow is the last day of revision. So tomorrow is when we cover up the last little bit parts that we haven't really covered. But I think for most of the part we're ready. It's just that you always need to cover the small parts here and there. But for most of the parts, I feel that we are ready. We are ready to take over. We are ready to take charge, and we are ready to show how much we've learned, what have we learned, and are we truly prepared. So as I promised is that from the looks of, if you go using the newsletter, you can find out that you guys are scheduled to write next Tuesday on the 21st of July. It will be a test that you'll be downloading. You'll be downloading from the site, and then after you download the test from the site, that's when you'll be able to write it. That's how you'll be able to write it. But above and beyond that, above and beyond that, there's the only thing I need you guys to make sure is that you understand the concepts and that you are ready, because I want us to be more prepared. I want us to go beyond just the lockdown, the digital school, and go beyond what we prepare for now. I want us to become fully prepared. I want you guys to be fully prepared so that whatever you meet when you enter the classroom again, you are completely ready. You are completely ready. Whatever you meet, no matter whatever challenge you may find, you'll be completely ready. Let me take a question, then I start. Hello.
Hello, sir.
How are you?
Fine, thanks. And you, sir?
I would have been better if it was warmer.
Sir, I have a question to ask.
Ask.
So, how many marks is the test going to be?
60.
60.
Huh? What did you do that? Grade 4, grade 4 is 57. We are of 57 for grade 4, yeah.
Oh. Thank you, sir.
No problem. No problem at all. Right. So, right. Here is my Twitter handle. Here is my email account, my email address. Please, if you meet any problems or you have any challenges, please ensure that you do contact me. If you meet any problems or challenges, please ensure that you do contact me. Make sure it's a requirement that you do contact me so that we can ensure that you are fine and prepared. Please, 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 quadruple, please ensure that you do contact me if you meet any problems. Let us start. So we're looking at geometric patterns and how to draw a line of symmetry. Right. So if you do not have the scope already, please write it down now. Oh, I forgot that there's also subtraction there, but fine. Please, if you do not have the scope, please make sure you do write it down now. Multiplication, it's addition, it's geometric patterns, it's division, it's word problems, and also there'll be a bit of 2D and 3D shapes. There'll be about 2D and 3D shapes. There'll just be a part about covering 2D and 3D shapes. So please make sure you have the scope. Don't forget to add 2D and 3D shapes to it. It's multiplication, it's addition, it's geometric patterns, it's division, it's word problems, and 2D and 3D shapes. 2D and 3D shapes. Are we done writing down the scope? Are we done writing down the scope? Do we have the scope? Do we have the scope? Are we done writing down the scope? Do we have the scope? Do we have the scope? We have a scope. Please write it down as quick as possible. If you are using technology, I said that you can always screenshot, screen grab, or screen record. Yes, so please make sure that you have it. So please don't forget to add 2D and 3D shapes. It's gonna be there. You're going to be asked about it. So I don't want you guys to end up being confused. It's going to be in your paper. It's going to be there. You're going to be asked about it. And you need to just know it a bit. Just know it a bit and you'll be fine. So can I please have notification of who is done so that I can start with the story? We can start with the lesson and have an interactive lesson I'll give 10 more seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Right. So a geometric pattern is a kind of pattern formed using geometric shapes and a repeated design. This also, guys, includes numbers, right? So a geometric pattern is a kind of pattern formed using geometric shapes and a repeated design. This also includes numbers they form also part of geometric. So please write this down. What is a geometric pattern? A geometric pattern is a kind of pattern formed using geometric shapes and a repeated design. So remember that in a pattern, like, okay, let me ask anyone here who can tell us what is a pattern. If I'm going to, one day you are in the shop and you are by the dairy products and someone comes to you and asks you to say, what is a pattern? What is a pattern? How can you describe a pattern? How do you best describe a pattern? What is a pattern? What are you going to say? Hello.
Hello, sir.
Hello, how are you?
I'm fine, and you, sir? Sir,
I would have been better if it's warm, but yes. If you're asked what is a pattern, what were you going to answer?
So I would say a pattern is a pattern that can repeat, or it can be a growing pattern.
But I want to ask, what is a pattern? If I say to you, that thing there is a pattern, what is that one thing that you know about a pattern that is always there?
The pattern is when it repeats, it grows, or you can use shapes.
Okay. You have a perfect description, right? So a pattern, one thing about a pattern is that there's always something that repeats itself, right? So, for example, look here. You've got 1, 1, 2, 3. Then you've got diagram 2, 1, 2, 3, 4, 5. Right? That means you've been added by what? By 2. Then you've got 1, 2, 3, 4, 5, 6, 7. Right? Meaning that since they're added here by 2, it was added by 4. So it's repeating itself by saying that each time here when we add to the original 3, we're adding the multiples of 2. There's a repeated design, repeated something about it. That's what a pattern is. A pattern is a repetition. A repetition. You know, when someone says that police, when they investigate crimes, like if they're looking at murder or they've seen the same thing about a murder, they say, no, this man uses the same form of pattern, or it repeats itself. The murders have a similar pattern. It means that the person has been doing the crime the same way over and over and over again. There hasn't been much change. Maybe the places have changed, but there's a repeated design. There's something that repeats itself. So please write this down. You have 1 minute to write it down or take a screenshot. You have 1 minute to write it down or take a screenshot. Or take a screenshot. Your time starts now. Your time starts now. So please, guys, I always say, take advantage of the technology. Please take advantage of the technology. Let the technology do majority of the work. So your only job is to think and see how much can you absorb within the time of the lesson. $30 seconds left. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Now, you've got two types of patterns. You can have a growing pattern and a repeating pattern. A repeating pattern, right? Please write this down. Please write this down. Sequence repeats itself, remain the same, never add anything, or the pattern never changes. So if the pattern is triangle, square, triangle, square, triangle, square, triangle, square, triangle, square, it's like that. Triangle, square, triangle, square, triangle, square, triangle, square. If we're dealing with numbers, I want to be perfect. Yes, so always it just repeats itself. There's nothing that changes. Even maybe we think multiples themselves are repeating because it's just adding 2 plus 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 2. You understand? But it's more understandable with shapes to say that, as I'm saying, it's just triangle, square, triangle, square, triangle, square. It's a repeated pattern. Then a growing pattern would be a sequence changes every time it repeats, right? So if I had a triangle square, the next time it would have been 2 triangles, 2 squares. Next one would have been 3 triangles, 3 squares. So now it's starting to grow. It's changing as now the pattern is going on. I started with a triangle square, then I said 2 triangles, 2 squares. Then I said 3 triangles, 3 squares. Then I said 4 triangles, 4 squares. That's a growing pattern. The repeating one is just triangle, square, triangle, square, triangle, square, triangle, square, triangle, square. But the growing one, there's something that changes. It's growing. It's becoming more. It's growing. Right. So having that in mind, I'm giving you 2 minutes to write down the information, take a screenshot or take a screen grab. Please, please, please write down the information. It's very, 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 very important. It's very important too. It's very, very, very important. Oh, it's very cold. Please write it down, and when you're done, please alert me in the chat. In the chat, please alert me when you are done writing down. When you are finished, when you have completed, please alert me in the chat. Right, it seems that I have questions. Hello?
Hello, Sam.
Hello, how are you?
Fine, thanks, and you, sir?
I am excellent.
Sir, can you please repeat the question?
Question?
Yeah. Sir, I have a question.
Yes.
So can a pattern be anything that repeats or grows?
Yeah. Remember, with geometric patterns, they sometimes mostly targeted towards shapes and you'd say numbers at times. But when you speak about a pattern in general, a pattern in general can be anything. Even if you look at clothes, you understand?
Yes, sir.
The color coding sometimes in clothes. You know, like when they say your shirt or your jersey is color blocking, and
Yes, sir.
it starts saying yellow, then it has a line of green, then has a line of yellow, then has a line of green, then has a line of yellow. Even
Yes,
when you
sir.
look at traditional clothing uses patterns. So in life in general, patterns can be anything. It's as long as there's that one thing that it repeats itself. There's that one element of it repeating itself. It becomes a.
Yes, sir.
All right, awesome. Hello?
Sir?
Yes, you have a question.
Not necessarily. So
Yes.
all patterns have to be growing patterns, or like do all patterns have to be growing patterns, or shape?
Or they can
yeah,
look
that's kind of
like,
all
for example,
can
um, it depends on the pattern you're dealing with, right?
okay, patterns. So what?
Like it depends on the pattern that you're dealing with, right? Sometimes, let's say you're dealing with um, shapes, right?
Yes, sir.
Shapes, they just like I was giving an example of the triangle, square, triangle, square, triangle, square. It
Yes,
ends
sir.
like that. So it's not always a must. It just depends on how did it start. That's why my advice is that I always tell people, even with the numbers, look at the first four numbers and how did they get to that number, or how did they get to that shape. For example, if we're looking at a growing pattern of triangle, square, we're going to, by the time we start saying 4 triangles, 4 squares, we would know to say that these things are growing one more, right? But if we see that it's just triangle, square, triangle, square, triangle, square, triangle, square, then we know that no, this is just, it's repeating itself. So it's not always a situation whereby you're going to find that it's always going to be repeating, or you're going to find it's growing. It depends on the question that you're dealing with and the pattern you're dealing with.
It's
Right.
so patterns cannot be like you do lots of different shapes every single time, or with different colors and different numbers and different amounts.
For example,
But like counting, like
for example,
yeah, like
as I made an example, it
yeah.
depends
So
initially on how the pattern is moving and how is it going.
okay, so
As I said,
a pattern cannot a pattern cannot be with different shapes or different amounts. Like for instance, first you're counting in odd numbers, then you start counting in even numbers, then you start counting in folds, then after thirds. You cannot do that.
but then what sequence are you following? Because if you start saying you counted in odd numbers, then you started counting in even numbers, then you started counting in odd numbers, then you started counting in even numbers. There's a pattern there.
Not
Odd
like
numbers.
that. Like you keep counting in all sorts of different numbers. Like first you
Like you
count
keep
in
on
odd.
changing.
Yeah.
If there's nothing that
Don't stay
shows
in
that,
like two or two, one or three of the same amount of numbers. You keep on changing and changing how much you have. Like until you get to tens. Until you count into tens, because all
so
your
there's
numbers
nothing
up.
that's either
And
growing or repeating itself.
no, so you cannot do that in a pattern.
So within it, is there anything that is growing or repeating itself within your pattern?
No, there's nothing.
Then it's not a pattern. If there's nothing that is showing as a repeated thing, or it's growing in the same particular way, then it's not a pattern.
Yes, sir.
It's something else.
Okay.
Like for example, look at, for your own time, look
Yes.
at terminating and non-terminating decimals, and then we'll
What
have
does
a
that
conversation.
mean?
Nah? For your
What
own
does that
for your own research, just look at terminating and non-terminating decimals. But let me move along because we know time. Time is very important. Right. Thank you so much. Right. So as we said, you've got repeating patterns and you've got growing patterns. As I said, you've got a rectangle, a triangle, a rectangle again, and then 2 triangles, and a rectangle, then 3 triangles. So the pattern can either repeat, or the pattern can either grow. Right. Then we've got with numbers, for example, increasing repeating pattern. Please, guys, write down these 4 examples while I explain them. Right? Write this one here, this one here, this one here, this one here. Going to explain them as slow as possible so you guys can write most of them. Right. For example, increasing repeating pattern. Here you've got 3, 6, 9, 12. It's repeating, same, being added the same way, right? And you've got 2, 4, 6, 8. So it's just times 2 times 2 times 2 times 2 plus 3 plus 3 plus 3 plus 3. Then you've got decreasing repeating pattern, -7. So it's 50 minus 7, 43. -7 again is 36. -7, -7. Understand? Like that. Where are you going here? 96. Oh, this was supposed to be divided by 2. 96 divided by 2, divided by 2, divided by 2. These are where it decreases, but it's a repeating pattern. Then here growing, it starts +2, then you change, +3, then change, +4, then change, +5. It's growing because the way you're adding and the sequence that it's following is that the way we add goes one more. So that's the repeated sense of it. Here as well, that when you're subtracting, you're subtracting a bit one, and not really say one more, but one less, because remember, the more the more I would not say the more the negative number gets higher in number. You understand? Because remember, with negative numbers, -1 is more than -5. But you understand that it says -2, then you went -3, then you went -4. This is the growing side of it. But here, this is where now we're saying it's just repeating to say, no, here we're just adding 2, here we're just minusing 7, we're just dividing by 2, multiplying by 2. It was repeating. Then here things change to say, no, I started adding 2, then I added 3, then I added. So each time you add, it becomes one more, one more, one more, one more, one more. If you want to check something, look at this thing, Fibonacci. There's a pattern called Fibonacci somewhere. Just look into it, just for your own time sake. Just look into something called Fibonacci numbers, and then you can just, for your own time sake. But as you can see that, so please write all of these down. I hope that you are done. If not, please take a screenshot. Please take a screenshot. But this is the numbers part about it. We saw with the shapes. Now we're seeing with the numbers. At the numbers themselves. You must, that's why I said, look at the first 4. Say, oh, okay. 2 to get to 4, I know I added 2. But to get to 7, I know I have to add 3. And to get to 11, I must add 4. Meaning my next term, I must add 5, because saying 2, 3, 4, 5. That's why I say always look at the first 4 or the first 3. That will give you a notification on how the pattern is moving, how it's actually operating. That's the one that gives you an idea. Are there any questions? Are there any questions? Patterns are not really challenging, but are there any questions? Hello?
Hello, Sam.
Are you awesome?
Yes, Sam.
I'm great. I'm great. You have a question for me?
Yes, Sam.
Yes.
So, Sam, is there only in numbers, can there only be a decreasing pattern and an increasing pattern?
Please rephrase your question. Like, in numbers, can they either only repeat or grow?
So they can only be repeat or grow.
Are you asking that?
Yes, sir.
Remember, as I said, that for something to be a pattern, there needs to be some way or some form that it was following. That's
Yes.
how something is a pattern. You understand? That's how something is a pattern. For it to, there needs to be something about it that shows itself. Like, for example, look at the one right underneath here. This one here. You see that the way in which we add to get the following number increases by 1. That's the pattern of it. The way we get the following number when we're multiplying increases by 1. That's the pattern of it. So if you find that you have numbers that are not related, that they are just numbers that are next to each other, then you can't really call it a pattern. You understand?
Yes, Sam.
There needs to be something that is showing that no, we were next to each other for a particular reason.
So,
You
Sam,
understand?
yes, Sam. So, does the same thing go for shapes?
Yes. Same thing for shapes. If I see, for example, like now I tell you that I see a hexagon next to a circle, next to a cylinder, next to a triangle-based pyramid. And then the question would be, what are these shapes just next to each other? What is it that what are they? How are they associated? Because if it was first a square, then it was a pentagon, then maybe it was a hexagon, then maybe it was a heptagon. You understand? That means that each shape that's following increases by one side. Understand? But
Yes, Sam.
else where it's just different shapes next to each other, they have nothing in common, they have nothing, they are not repeating any sense or whatsoever, then we can't call it a pattern. They're just shapes that are next to each other.
Yes, Sam.
All right. I hope I've explained it enough. I hope we're done as well with writing down this. I want to go now and I want us to just test our knowledge. I want us to test our knowledge a bit. I want us to. Right. Please try for us. I want us to try number 2 and number 7. Number 2 and number 7. Let's talk. Number 2 and number 7. So try it out and then for 2 minutes now, try it out and then we'll speak to say that what is it about it? What pattern? I'll give you 2 minutes and then we'll talk about it. And then after that, after speaking about it, we go to the lines of symmetry and then we're done. So try number 2 and number 7. What is it about number 2 and number 7? How did you get the following number of number 2 and number 7? So look at number 2 and number 7 and see how did they get the following number. Right, I found my first victim. So you'll be the first one to respond to us after the 2 minutes are over. Number 2 and number 7. 2 and number 7. How did they get the following number? Number 2 and number 7. Number 2 and number 7. Look at number 2 and number 7 and complete it. Number 2 and number 7. Number 2 and number 7. Number 2 and number 7. Ten seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Hello?
Good afternoon, sir.
Hello, how are you?
I'm fine, sir.
I'm
Yeah,
good. So how did they get the answer for number 2 and how did they get it for number 7?
I counted in tens.
For number 2,
Yes.
what made you see that you must count in tens? What made you notice that you must count in tens?
I counted, then I checked, then it showed me I counted in tens.
All right. And then for number 7?
It's counting in 15s.
Awesome. Awesome, 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 awesome. As we can see, the pattern here, to get from 15 to 25, you add what? 10. To get from 25 to 35, you add 10. So it's 10, 10, 10, 10, 10. Here, 15. 15 plus 15 is what? 30. 30 plus 15 is what? 45. 45 plus 15 is what? 60. You are done. You are done. You are done. You are done. You don't need to do a lot. Let me go to lines of symmetry. So symmetry is when a shape or object has two completely identical sides on either facing each other. A line of symmetry is the line that divides two identical parts, each part being a mirror reflection of the other one. So when you are looking at symmetries, that when I want to cut this square here into half, I'll have two halves that are exactly the same when I fold them. When I fold one half into the other half, they'll be exactly the same. If I fold it this way to the other side, it will be exactly the same. That is what symmetry is. Symmetry is that when you fold it or cut it or put it on top of each other, one side on the other, the two sides will be exactly the same. That's what we mean when we say something is symmetrical. When something is symmetrical, one side is the mirror of the other side. That's why sometimes they say that the human face may not be symmetrical because some people, some people have a different size, like one side of the nose is bigger than the other side or something like that. Some people, you do meet a situation like that. It's not like there's an abnormality, but it's true that if you look at your ears, I always make an example that if you look at ears, even myself, I look at my ears sometimes in the mirror. I find that one side of my ear, one ear might be a slightly bigger than the other ear. But when we speak of symmetries, that it's completely identical, that if you are going to fold it, it will fold into one shape, right? So please write this down. You have 2 minutes to write down this. Please write it down. That is what is symmetry. Symmetry is that when I look at the shape, like even if you look at the rhombus and we cut it here and I fold it, this side folds directly into this side. Even if we put a line through here and we fold it, one side folds directly into the other side. That is what we say symmetry. They are symmetrical. They can form mirror images of each other. Then they say mirror image or mirror reflection. That's what they mean. Symmetry. That's what we're talking about when we're speaking about something is symmetrical. When something is symmetrical. Symmetry. That's what we're speaking about. Something becomes the mirror reflection of something else. You have a minute left, 1 minute, and then we go and just try a quick exercise. And then after trying the exercise, we are done. Does anyone here have a comment or anything about symmetry? Wants to add anything about symmetry? Let's check. It's not working. Oh, hello. Maybe it's the mic. All right, it's fine. It is fine. It is fine. It is fine. 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I hope we are done. 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 Can I please get a notification if we're done in the chat? Can I please get a notification if we're done in the chat? All right. Looks like we are done. I hope we are all done in the chat. There's right. So I think we are done. We've written. Please, guys, also make sure that your videos are off. Awesome, 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 awesome. This is what I like. This is what I love. This is what I call fantastic. Fantastic. Let me just, looking at our time, because time is always of the essence, we're going to try. Here is your homework, right? Here is your homework. Draw a geometric pattern using 2D shapes. Then write 3 increasing patterns using numbers. So you draw a geometric pattern using 2D shapes, and then you write 3 increasing patterns using numbers. Then you can send that beautiful homework to me via email. Right? You can send that beautiful homework to me by email. Directly to me by email. I'm putting my email address in the chat, and also my email address was the first thing that you guys saw. So yeah, that's it. That's it. That's it. That's it. That's it. All you need to do is draw 3 geometric patterns using 2D shapes, and then write 3 increasing patterns using numbers. They must be different. They must be different. Requirement, they must be different. Is there any question, any problem, anything from anyone? Anyone wants to add anything? Anyone wants to add anything, any question, any query, anything? Right, so I've got 3 hands. Seems not to be working. What's happening now?
Hello.
All right, here we go. Hello? One more time.
I
Hello.
don't have any questions.
Nothing at all.
No, sir.
All right, awesome. Hello?
Hi,
Hello?
sir.
I'm good. Do you have a question?
Sir? No, not necessarily.
Nothing.
Sir, did you know that the triangle actually has 3 ways that it can be symmetrical?
Oh, which way? So is it up and down? Then where and where?
It's in the middle.
Yes.
If you can go to at the bottom end of the corners,
So
you
let's just see it quickly. Right.
Yeah.
So here's one. So it's one here and then one here. Then what?
Then
It would be one here.
Yes, one here, and then after straight up.
Okay. One here and then what? One here.
Yeah. That's the 3rd way.
Fantastic. 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 Right. Since there is nothing else, let me take my leave. Yeah, we're closing off early by 1 minute today. Let me leave. Goodbye, guys. You are awesome. You're a fantastic group. I love you all. Bye-bye. Bye-bye.